Hello everyone, in this video we will understand the concepts around transfer learning. Transfer learning is an important aspect in deep learning. First, let us understand the intuition behind transfer learning. Human brain uses transfer learning in everyday life. For example, let us say you teach the rules of soccer game to someone. Upon learning, if you introduce the game of hockey to that person can infer the learnings from soccer and can adapt it to hockey. There could be some variations, of course, like foul in soccer happens when a player touches the ball with hand, whereas a foul in hockey happens when a player touches the ball with foot. But the differences aside, there are many similarities like penalties, how the goal is scored, etc. And those similarities could be applied and transferred. This is an example of a brain performing transfer learning without our knowledge. Now let's take a look at an actual use case. Let us say we want to classify vehicle models by looking at images of cars. Now if we want to do this from scratch, we will require sufficiently large dataset of cars, of course, which labels, and enormous computation power. It takes a lot of computation power to train and tune the hyperparameters. This is a perfect example where we can use transfer learning. Now let us understand how transfer learning works. Let us take an existing dataset in a similar domain. For example, we have a dataset which classifies objects as cars, tables, chairs, etc. This use case is known as object detection, and there are plenty of datasets around this. We can build a deep learning network consisting of several layers and train the network on this data. Once the network is trained, then we can apply transfer learning to transfer the knowledge from the source network to a target network. Now we can feed the input data, the car images and labels, to the target network and then get the classifying output. Now we can ask a question, again we are training from scratch, but we need not train from scratch. Instead, we can use a pre-trained model. The pre-trained model would have been trained on the object dataset and it performs object classification. A pre-trained model is just a model which is already trained on some dataset. Now, how do we use this pre-trained model? There are multiple approaches. Predominantly, there are two approaches which we'll see in further sections. We can either reuse the entire network with all its weights, or we can use parts of it. Now let us understand how learning happens in neural net for a bit before we actually jump into transfer learning. A deep learning model learns the features in a data by encapsulating the learnings in the layers. The learning is the weights of the neurons in each of the layers. The low level features like edges, points, etc. in an image, in object image, are generally the generalized features. They are common to all images of objects regardless of what that object is. And these are learned by the bottom layers of the neural network. These specialized features like what is a car, identifying a table or a chair, these are learned by the topmost layers of the neural network. So this is very important to learn. The bottom layers represent general features, and the top layers, as we go on top, they learn the specialized features. Now let us take a look at the two approaches we can use while performing transfer learning. The first approach is a freeze approach. Here we use the source network as a feature extractor. That is, the source network plays the role of extracting the generalized or specialized whatever features from the dataset. In this case, we remove the topmost layer from the source network and replace it with a custom classifier layer, because the topmost layer generally classifies the object. In case of object detection, the topmost layer classifies the data as chair, table, etc. But in our case, we need the classifier to classify models of the cars. That is why it's different. So the topmost layer, the classifying layer, will be replaced. However, if you notice, the rest of the layers we have frozen, which means we are reusing the weights of the pre-trained model as is. So this is the first approach. In the second approach, which is called a fine-tuning approach, we still remove the topmost layer and replace it with a custom classifier layer. However, we will fine-tune the other layers of the network by retraining on the new data. If you see here, the bottom layers are frozen and the top layers are fine-tuned. So this we can take a call which layers need to be frozen, which layers need to be fine-tuned. We can fine-tune all the layers or few layers depending on the use case. So this is the second approach. Now a question comes to our mind, which approach to use? Now we can formulate some rules based on the dataset size and the similarity of domains. If we have a smaller dataset size, we should freeze the layers and use the pre-trained model as a feature extractor. Because when we have smaller data, if we try to fine-tune, the model will get overfitted. Here, if the domain is similar, we can freeze all the layers, and if the domains are not similar, we can freeze the bottom layer only, so that we can reuse the generalized learnings. Now, if we have larger dataset size, we can fine-tune the source network to learn the specific features of the target data. Because we have plenty of data, we can fine-tune some of the layers or all the layers depending on use case, so that the network will learn the new features of the new data. So overall, these are the two approaches we can use in machine learning, in transfer learning. We can also use mix and match of these two approaches, as we have seen. A final note on pre-trained models. There are plenty of pre-trained models offered with variety of licenses. Some are open source, some are licensed for commercial usage, spread across computer vision and natural language processing. Some of them are mentioned here. Some of the most popular ones are GPT-3, BERT in NLPs, and we have similar pre-trained models in the vision side also. You can visit modelzoo.com for the URL provided here for more details. So that's it for this video. I hope you liked it. Thank you for watching.